In order to do the problems in section 7.4, you first have to learn and memorize the double angle identities. Here they are. Notice that there are 3 different versions of the cosine of twice an angle. You're going to use different versions of cosine of 2a depending on what you're given. If you're given information about sine a, then you can use this version. If you're given information about cosine a, you could use this version. If you're given information about cosine and sine, you can use this version. So it depends on what version, it depends on what information you're given, what version you're going to use. There's really only one version of the sine of a double angle. It's pretty straightforward. It's 2 times the sine of a single angle, cosine of a single angle. And then there's only one version of the tangent of a double angle. It's 2 tan a over 1 minus tan squared a. So we're going to be referring back to those as we do the problems. The first type of problem on page 673, example 1, you can walk through the one that's in the book, also in the PowerPoint. Here's a very similar problem, just with different numbers. I thought I'd walk through for you. So you're given the sine of an angle, so that's a single angle, is 8 over 17, opposite over hypotenuse, and cosine is less than 0. Well, if you think about that, the fact that sine is a positive ratio would put this angle in either quadrant 1 or 2. When it says that cosine of the angle is less than 0, well, that's got to be negative. That's got to be quadrant 2 then, because cosine is negative in quadrant 2 and 3, sine is positive in 1 and 2. They both have quadrant 2 in common. So you know that the angle, theta, is in quadrant 2. So you might even say that over here. Theta in quadrant 2, just to remember. Anyway, they want you to find the sine of a double angle, cosine of a double angle, and tangent of a double angle. Well, sine of a double angle, it's that straightforward formula. Sine of twice theta is 2 times sine theta times cosine theta. It's really straightforward, and if you think about it, and we've done this before, you can make a little template, right? This is 2 times a ratio times another ratio, because sine of an angle is a ratio, cosine of an angle is a ratio. And the sine of theta is given to us, it's 8 over 17, so you can plug that ratio right in here. So we can't plug in this ratio because we don't know what the cosine of theta is. We know it's negative, we don't know exactly what it is. So we can do this one of 2 different ways. I'm going to show you the trig identity ways first because that's what we're learning. Later on, I'm going to show you sneaky, more intuitive triangle methods. So in step 2, I think, well, if I know information about sine and I'm trying to find cosine, what identity can I use that relates sine and cosine? Well, I can relate the identity that says sine squared. Sorry, that looks really awkward. Try that again. Our production values are basic here. So this is sine squared theta plus cosine squared theta equals 1. So we're going to use that. Okay? We know that sine is 8 over 17. I know that if I subtract sine squared from both sides, I'm going to have cosine squared theta equals 1 minus sine squared theta. 1 minus, I'll put parentheses here, right? Sine theta squared goes right in here, and I know that sine theta is 8 over 17, so I can plug that right in here. So notice, in order to do this problem, I'm using the sine double angle formula, and I'm plugging in what they give me for sine here, I'm plugging in what they give me for sine here, and I'm using this identity. So remember, if I square this, I'm going to get 64 over 289, right? That's 8 over 17 squared. And in order to join these two together, one's going to come disguised as 289 divided by 289. I kind of joined all these together. Be a little bit neater. Wow, neatness counts, go figure. Right? That means I can combine these. I can put these underneath. Common denominator has 289. This is 289 minus 64, which is 225 last time I checked. So that means cosine squared theta is 225 over 289. Remember, I want cosine theta, not cosine squared theta. So if I take the square root of both sides, I'll get the square root of 225 is 15, and the square root of 289 is 17. It doesn't always work out. Sometimes you get radical answers. You got to use those radicals, no decimals here, right? Ooh, remember when I take the square root of both sides, I get a plus or minus as a result. But remember, theta, up here we said theta was in quadrant 2. We also said cosine of theta is negative. So we're going to use just the negative root of that. So negative 15 over 17, that's what cosine theta equals. So I'm going to plug that right in there. Negative 15/17. So now I come back here, and then part 1 of this problem, right? There's 3 parts. They want me to find sine 2 theta. I'm using the sine of a double angle. This is a double angle identity. So we're just multiplying numerator times numerator, denominator times denominator. In the bottom, I'm going to get 17 times 17. I'm going to have a positive, positive, and negative. So it's going to be negative. Right? And I do the denominator first because that makes it really easy. 289. And I'm going to multiply 2 times 8, 16 times 15, or I can think of 2 times 15 as 30, 30 times 8, 240. However you want to chunk that. This is the sine of our double angle. So that's the step 1 answer. 1 part down, 2 to go. Third one's going to be really easy. All right, so the next one we want to, I'll section off my work here so I know that that all went together. Now I want to find the cosine of a double angle. That's step 2 here. Cosine of a double angle. And gee, what formula do I want to use here? If I go back to my formula sheet, cosine of a double angle. Oh, remember, I was given information about sine. In fact, there it is right up here. Sine theta 8 over 17. I'm going to use that again, right? I'm going to use cosine of a double angle equals 1 minus 2 sine squared of a single angle. So right here, I know that 1 minus 2 sine squared of the single angle. And this becomes 1 minus 2 times sine squared. Sine is 8 over 17. So now I run the math here. Well, this is 64 over 289. We did that math already over here, but remember we're going to multiply the numerator by 2, so it's 2 times 64. It means it's 128. 2 times 64 is 128, and I've got a 289 in the bottom. Well, let's just join this all together, right? 1's going to come disguised as 289 over 289. So here's my 1 minus 2 times 8 over 17 squared. So I subtract 128 from 289, and I think I get 161. Yeah, I do. So that means cosine of 2 theta, 289 minus 128, 161 over 289. And that is the correct answer for the cosine of a double angle. Notice this gets easier and easier as we go through it. We did less work to find cosine of a double angle as we did for sine. All right, so here's even less work. Tangent of a double angle. That's step 3. Well, remember, tangent equals sine over cosine. So the tangent of a double angle equals sine of a double angle over cosine of double angle, right? Tangent, sine over cosine. This angle is the same. As long as the angle is the same in all cases, that works out. So let's put that over here. We have tangent of our double angle, sine over cosine, And sine of a double angle was negative 240 over 289. So negative 240 over 289. So there's sine of a double angle. Cosine of a double angle is right here. That's 161 over 289. You should already be seeing, wow, this is going to work out really well. Because remember, dividing by a fraction is the same as multiplying by the reciprocal. So it means we have a negative numerator, 240 over 289, times the reciprocal of 161 over 289, which is 289 over 161. Wow, the 289s are going to divide out. That leaves us negative 240 over 161. So tangent 2 theta, leave a little room for the negative sign here. Tangent of 2 theta is going to equal negative 240. Right? Remember, we're dividing out these 289s over 161. That was a piece of cake. Easy as pie.